The next video in a series I'm calling Fun Probabilities, we're going to look at probabilities with cards. Now these are all taken from actuarial exams and specifically from the playlist that I have called Free Actuarial Exams. So here, number one, current card hand has 2 kings, 1 queen, a jack, and a 10. 3 more cards are selected at random and without replacement. What's the probability the hand will have at least 3 kings? So the answer is, let's let X equal the number of kings drawn. And so X can only take on 0, 1, or 2. Right? Because there's already 2 kings in the hand, there's 2 kings left, and you could have 0, 1, or 2. Now we think about this as separating the deck into 2 kings and 45 non-kings. And then this is the classic hypergeometric setting. So the probability that X is greater than or equal to 1, which means that we end up with 3 or 4 kings, is the probability that X is 1 or the probability that X is 2. And so this represents the kings, this represents the non-kings. So out of the 2 we draw 1, out of the 45 we draw 2, and there's a total of 47, choose 3. And this one is the probability that X equals 2. So 2 kings, choose 2, 45 non-kings, choose 1. The total is 47 over 3, choose 3, which is 135 over 1081. Next example, a card is drawn with replacement 5 times. Find the conditional probability of drawing the ace of spades exactly 4 times, given that the ace of spades is drawn at least 4 times. So here's the answer. So if we let xi draw an ace of spades on the ith draw, xi is a Bernoulli random variable, 1, and the probability of drawing an ace of spades is 1 over 52. So this random variable is a 1 if we draw an ace and a 0 otherwise. And we're asked about the sum of these 5. So xi summed from 1 to 5, representing the 5 draws with replacement. And we want to know about y. But we know sum in Bernoulli's is a binomial. So y is a binomial with 5 and 1 over 52. If we look at the probability of y being greater than or equal to 4, that means x is 4 plus x equal 5. Probability that x equals 5. And then this is a binomial, so it's 5 choose 4, 152 to the 4th, 151 over 52. That's the probability that x is 4. Now the probability that x equals 5 is this. 5 choose 5, 1 to the 52 raised to the 5th. This is 56 over 52 to the 5th. Now to calculate the probability of interest, the probability that we have exactly, we've drawn the ace 4 times, given that we've drawn it at least 4 times, is this. So it's the intersection of those two, which is just y equal 4, right? The intersection of y equal 4 and y equal greater than or equal to 4 is just y equal 4. And then that piece is the probability that y is greater than or equal to 4. Well, this is a binomial, so you plug it into the binomial formula, same as this piece here. And then this is the probability that y is greater than or equal to 4, which we calculated. You simplify that, you get 255 raised or over 256. So almost a probability of 1. Problem number 3. 13 cards are chosen without replacement. What's the probability of exactly obtaining 3 aces? So think about this separating the deck into 4 aces and to 48 non-aces. And if we let x equal the number of aces, then this becomes the classic hypergeometric problem. So the probability that x equals 3 is of the 4 aces, choose 3. Of the 48 non-aces, choose 10. And there's the total number of ways to draw 13 cards, 52, choose 13. And then this is the probability. So it's 4.1% chance of drawing exactly 3 aces. A drawer contains, so this problem isn't exactly cards, but it reminds me of maybe one of my teenagers. A drawer contains 6 blue socks and 4 white socks, 2 socks chosen at random. Find the probability that the socks match. So let's let X equal the number of blue socks. So X can be 0, 1, or 2, right? We're picking 2 at random. And if the number of blue socks is 0, that means we grab 2 whites. If X equal 2, then we grab 2 blue. So we're interested in the probability that X is 0 or X is 2. Well, this is a classic hypergeometric setting. Of the 6 blue socks, choose 0. Of the 4 white socks, choose 2. Over the total ways to choose 2 socks, 10 choose 2. And then this is the probability that X equals 2. 6 choose 2, 4 choose 0, 10 choose 2. That simplifies to 7/15. Well, that's all I have for today. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.